Hello student, in our last video lecture we have learned the unrestricted earth fault protection in which the protection earth fault protection responds for both external fault and internal fault, that is it has no definite zone of protection. Now in this lecture we are going to learn the restricted earth fault protection. It means the protection responds to internal fault only and the fault location is restricted to a certain location on the transformer winding. Now let us consider the delta star connected transformer in which on delta side the overcurrent relays are used and earth fault relays are used for the protection purpose. On the secondary side, the star connected and three cities are connected in the three lines and their output is given to the earth fault relay. Similarly, one more city is connected in the earth to neutral connection and its output is also connected to the earth fault relay. Now, in this case, let us consider the fault on the external fault, that is fault outside the city locations, say F1. When the external fault F1 takes place, it completes its path like this. It goes to the earth, to the neutral, to the windings, and in this way, the current I1 and the current I2 is nearly equal, and therefore, earth fault protection does not respond. That means earth fault protection does not respond for the external fault. Now let us have the internal fault on at any location on the winding. Now let us say the fault takes place at this point on the winding. Now it completes its path, say from F2 to the earth to the neutral and again neutral to point A. In this way it completes the path, fault current path, and there is no reflection on the uh, cities connected in the lines, and therefore the current I2 is much more greater than the I1 and therefore relay operates. Thus the protection responds for the internal fault only. Now let us consider the rating of this secondary winding is say 400 volt, and therefore per phase voltage is 230 volt, that is the voltage between neutral and any terminal of the winding is 230 volt. Note that voltage at the neutral is 0 and it goes on increasing toward the terminal. Now if the fault takes place near to neutral, then the voltage available to force the fault current is very small, and therefore resultant earth fault current is very small, and the earth fault relay is too sensitive to sense such a small fault current. Then it may respond for the external fault and the switching over voltages, and therefore it is general practice to provide uh, to set the relay such that it operates for earth fault current 15% of the rated winding current. Such a protection protect the restricted portion of the winding and hence the name restricted earth fault protection. Now let us turn to the inrush current protection. Now here when unloaded transformer is switched to the system, it draws very high magnetizing current. This current may be a 6 to 8 times the rated current, and therefore very high magnetizing current is on the primary side whereas the transformer is unloaded, and therefore differential protection operates response. Now let us see the magnitude of inrush current depends on the following factors, that is the circuit parameters, voltage at the instant of switching the transformer, residual flux in the core, magnetic properties of the core material, size or rating of the transformer. Now the inrush current, this magnetizing component has a waveform. It is a non-sinusoidal and it has a spikes as shown, and this is for the normal current. The peak value of the flux in the transformer core during switching equal to phi r plus phi m cos theta minus phi m cos omega t plus theta, where phi is the peak value of the flux, phi r is the resultant residual flux, and theta is the switching instant. Let the transformer is switched on at theta equal to 0 and omega t equal to pi. Therefore, the resultant flux phi equal to phi r plus phi m minus phi m cos pi, and therefore resultant flux is 3 times the maximum flux. Therefore To create such a large flux, the transformer primary draws very large magnetizing current, and therefore it is necessary to provide the protection against the inrush current. Now, here it is a very important point to remember. The fault current contains only the 50 Hz components, whereas the inrush current has fundamental 100% component plus the second harmonics 63% and third harmonics around 27%, and 4, 6, 7th harmonics are around 10 to 12%. That is, the second and third harmonics are the dominant one. Now, the such a protection for such a protection, additional harmonic restraint coil is provided, in which filter is such a way that it filters the 50 Hz component and provide it to the operating coil, which produces the operating torque, and the 50 Hz components plus the high frequency components are fed to the restraining coil, which produces the restraining torque. And as the restraining torque is greater than the operating torque, the protection does not respond. Now let us have a little look on this block diagram. The city secondary currents are I1 and I2. Out of that, I1 minus I2 is the spill current in the relay, and which is filter. The filter gives the 50 Hz component to the operating coil, which produces the operating torque, and remaining, that is higher harmonics, and this 50 Hz component plus all higher components are fed to the restraining coil, and therefore it produces the restraining torque, and as the restraining torque is quite larger than the operating torque, there is no operation. Now let us study the overfluxing protection. The EMF equation of the transformer is given by E equal to 4.44 phi m F into N, and therefore phi m equal to phi divided by 4.44 F into N, and therefore maximum flux is directly proportional to phi by F, that is Bm is proportional to phi by F. This ratio becomes high, therefore flux density also increases, and this happens. Now what are the reasons for overfluxing? This happens at the generating stations if the full excitation is applied to the generator before it reaches to the synchronous speed. As the full excitation is provided to the generator, it generates more voltage, and as it does not reaches to synchronous speed, the frequency is less. That is, the voltage is more and frequency is less. It results into high V by F ratio, and as the high V by F ratio, the higher the core losses and core heating takes place. Another reason is at power frequency due to switching surges. Now switching surges are generally 1.5 to 2.5 times the 5 times the rated voltage, and therefore the V by F ratio is large. And because of this reason, the power transformers are designed to have this ratio 1.1 for continuous operation, and therefore the Vn upon Fn into 1.1 equal to V by F, where N stands for normal voltage and normal frequency, and therefore V upon F divided by Vn upon Fn equal to 1.1 for the continuous operations. Now the ability of the high V by F is limited to a few minutes only. When the V V by F upon Vn upon Fn, this ratio is 1.1. It is a continuous operation. But when this ratio is increased to 1.2, the withstand capacity is only 2 minutes, and if it is further increased to 1.25, the withstand capacity is 1. Therefore, the V by F relay is provided in automatic voltage regulator in case of generator, and in case of transformer, the here the transformer, the PT secondary is connected to the V by F detention circuit. Then the comparator is used here, and reference DC reference signal is provided. The comparator gives the signal to the trip circuit of the circuit breaker. Now when the in case during the overfluxing, V by F ratio increases, and when it becomes more than the set value, that is 1.1, the relay operates and disconnect the transformer. In this way, it protects the transformer from overfluxing. Today, I am going to stop here. In this lecture, we have learned so many things. Let us review them. So we have learned in this lecture the restricted earth fault protection, which which responds only for the internal fault and to a certain location of the transformer winding. Then we have learned the inrush current. And because of heavy magnetizing current, when the unloaded transform is connected to the system,